Hey everybody, it's Mr. Carr again. Today we're going to be starting up with 6A Day 1. Solve and graph one variable linear inequalities. Okay, so looking at linear inequalities, let's talk about some vocab to start. You've probably seen these symbols before, but let's just make sure we understand them. So we have this right here. The phrase is less than. Okay, the circle, when we graph this, you're going to use an open circle. Okay, direction to the shade is going to be to the left for less than, as long as we have our inequalities written with a variable first. You'll see what we're talking about in just a minute here. This is for the phrase is greater than, also the open circle, but this is going to go to the right. Is less than or equal to. This is going to get a close. So these are called open, and this one's going to be closed. This one also shades to the left like the first one. And this one is greater than or equal to. Again, it's a closed circle. And this one shades to the right. Okay, so when we graph these, we have to make sure we completely understand which of these inequalities we're doing, because this is how we communicate that. Okay, this is what the graph is going to look like. So the idea is that whatever statement you can make, you can represent with one of these, and somebody else can look at it and knows exactly what you're describing. So graphing inequalities. You need to include two things: shading to the left, and that's anytime it's less than, or right is greater than. I guess I could just the symbols. Less than and greater than. And also needs an open or closed circle on the border number. Okay, so again, open means open circle, closed means that. Okay, this is the less than or greater than sign. This is the less than or equal to, greater than or equal to sign. So border number is referring to the value that we're looking at. X is less than 6. So if I go to 6, this is my reference right there. That's my border number. It's a less than, so that means it's going to get an open circle. Okay, and then I'm going to shade to the left. That's it. As long as I have it look like this, where the variable is less than the number, then that's how my graph looks like. Okay, now what this means here is with an open circle, it excludes x equals 6. Okay, this number is not a part of it, because for example, if I take 6 less than 6, is that true? No. Okay, but if I take any number in the shaded area, that will be a true statement. So for example, is 1 less than 6? Yes. Is -5 less than 6? Yes. Okay, so that's what we're representing here. All of these numbers make this statement true. Okay, anything that's over here, like 7, is 7 greater than 6? No. So that's everything that's not in the shaded region is not a solution. So an open circle is also not a solution here. When we look at this one, my reference number is -5. So we're looking at this one right here. It's a greater than or equal symbol, so that's going to be a closed circle. And it's greater than, so that means it's going to the right, just like that. And again, everything in the shaded region is a part of it. So is 1 greater than or equal to -5? Yes. Is -1 greater than or equal to -5? Yes. What about -5? Is that greater than or equal to -5? Because of the equal, it's greater than or equal to, that's a yes as well. That's why we do a closed circle. We includes x equals -5 here. That's a part of our solution. Okay, open circle means excludes, closed circle means includes. Okay, so that's what we're looking at there. Solving inequalities. We are going to be doing this. This is a good callback to our unit. Oh man, unit 2. It's a while ago. Okay, so we're going to, the goal is to always make sure that we're reading it left to right. That's number 1. So anytime that we're dealing with variables, make sure the variable is on the left side. Okay, the other part of our solving process is we're going to solve it just like other equalities back in unit 2. The only things that change is if we multiply or divide by a negative number as part of our solving process. If we do that, the inequality sign flip-flops. Okay, so as a quick example looks something like this. If I have, let's say, negative 2x is less than 10. Okay, if I divide by negative 2 to both sides, I'm dividing by a negative. So that's going to turn into x is greater than negative 5. Okay, so that's what we're looking for. Multiplying or dividing by a negative number is going to flip that inequality. So let's take a look at some examples here. We're going to solve these and then graph them on here. Oh, hello. Okay. So solving process, again, you could just treat it exactly like it was way back in unit 2. We look at this, we're going to combine like terms. So we got negative 18 greater than, that will be negative 6 plus 4b. Now I'm going to add 6 to both sides. So that's going to give me a negative 12 greater than 4b. Now I can divide both sides by 4 and I get negative 3 is greater than b. Okay, now remember step one, or things to remember. Number one, we always want to read it left to right. This right here is a little bit trickier to try to graph if I try to go right to there. Negative 3 is greater than b. That's what this means. Negative 3 is greater than b. Okay, so first of all, I'm going to put an open circle on negative 3. I know that's my border number there. But when I do my shading, it makes me feel like I want to go to the right because the way it's pointed. But the problem is, if I flip that and I read it right to left, negative 3 is greater than b, but then if I go right to left, that's b is less than negative 3. So I can actually flip that around. These statements are the same. B is less than negative 3. Now that I've lined it up with the variable, oh, hello, hold on a second. Gotta fix that here. There it is. Sorry about that. Bottom line is if I read it right to left, b is less than negative 3. This value here is less than negative 3. So that's how I'm writing it here. So negative 3 is greater than b, same thing as b is less than negative 3. Now that I've written that way with the variable on the left side, and I read that, that means I'm shading this way. If you're ever not sure, pick a value and test it. For example, if I do negative 6 here, is negative 6, well, even if I do the first one, if I did is negative 3 greater than negative 6? Yes. So I know that negative 6 is a part of my solution. But if I did over here and I did like 2, is negative 3 greater than 2? No. Okay, so that's how I knew this was not a part of it. Part B, we're going to solve this one. First thing we want to do is let's get rid of those parentheses and we're going to distribute it. So negative 6 minus 12 plus 8x less than or equal to 5x minus 15. We're going to combine our like terms here. So that's going to give me a negative 18 plus 8x less than or equal to 5x minus 15. We can bring our x's together, combine that way. I'm also going to do is one step here and make a little bit of a shortcut. So that way I get rid of my x's here, and I get rid of my numbers here. So I end up with 3x less than or equal to 3. Then I divide by 3 to both sides. And again, I did not divide by a negative, so I'm not flipping my sign. So x is less than 1, or sorry, less than or equal to 1. Here's my border number at 1. It's already written left to right, so I don't need to change anything. So I'm just going to go this way with that. And that's it. That's our basic inequalities. So we are going to take these and go a little bit further with them in each of these lessons, but that's our start. Inequalities, one of the big differences you notice, there is a whole bunch of numbers that work for what we're dealing with. Any equalities, we're only looking for one answer. Now we're looking for a whole range of answers. Okay, so that's it for 6A, 6A day 1. So we'll continue on in the next video. Sorry, excuse me.